be like a 30 seconds of us idle chit-chatting. Oh, what's this? The Bin podcast just went live. Let me share this with all of my cool friends who are in...
That's me.
One guy?
Ooh.
Cool friend?
He did say plural, so he did use friend as the best, so it implies more than one. And he's my friend, so you know.
I brought a
See,
cool
we got it.
I'm gonna host
Integers
that.
greater than one.
There we go. I've done my bit. Gonna go home now.
Yeah, wait, you just shared the post, so you're good for the day. Thank you so much for your contribution.
Bye.
See you later.
It's more than usual.
He's doubled his normal output.
Oh,
Should be on a bonus.
Who's sending me friend requests?
I guess they like your show.
That was quick.
Oh, sure, Taylor's
Probably one of my
watching
cool friends.
Oh,
Hey, and he shared it. He just doesn't want to join in.
cool. Why can I not find our own... Oh, there it is. Okay. I was like, what? I've been blocked.
Your friend blocked you? What?
Looks like we are all good. We can go ahead and fade this music down. And switch scenes. Alright. And we got spinny faces. There we go. Hello, Internet, and welcome to another Thursday Spectacular edition of the Bin Podcast. I'm Mikey Famine.
That is true.
Down below us, Wayne and Cortez. Brenda to the far side. And we have a very special guest right here in the middle of the screen. How apropos. Landon Curt Noll. Hello, Landon. How you doing?
Good morning, good afternoon, or good evening, depending on your time zone and latitude. And I hope folks are doing well out there in land of Covidia. And we're here going to chat and hang out. And I understand, today is actually a special day.
Not that special, but yes, somewhat special.
And it's special because...
Go ahead, drop the bomb.
It's my birthday.
Hey!
So...
Another year of being sexy.
So for Wayne, happy birthday to you.
Oh.
Happy birthday to you. Happy birthday, dear Wayne. Happy birthday to... Happy birthday, sir.
Yay.
Congratulations.
Yay.
Thank you very
Happy
much.
birthday.
Do you want to come back every week? Because I like this.
So and on your birthday, of course, you can extend it, right? When I do my birthday, I center it around the minute I was born of that day, of the time zone that I was in at the time, which I have to adjust because I was born on standard time, and now that date is daylight savings time. So I have to do that adjustment as well. But it turns out that for me, I celebrate my birthday if there's any time zone on Earth that has my same calendar day. I was born on October 28th. It's on Wikipedia, so it's not a secret. And so it turns out there's a 50-hour period of time because you have some time zones that are actually like plus, I think it was like one is plus 14 and one's minus 13. So you have a time period where as long as there's a time zone that's October 28th, it's my birthday and you get to celebrate. So you get this whole 50-hour long
that's
deal.
what I'm talking about.
Well, being that I was born in Greenwich Mean Time, I've got a massive... I can have my birthday all week.
Well, and it is so it is the case, for example, that you have there's a zone which is GMT plus 14 hours, and there's actually another zone which is GMT minus 12. So that gives you a 50-hour span because you have the full day plus that extent where you can always say somewhere on my thing is a birthday. And I usually try also to call on my friends at the South Pole, which is right here on the T-shirt. That's what this T-shirt is. If you go to the South Pole, you can go to the gift shop and you can buy this T-shirt.
You mean
and so I usually have them go out. Well, actually, apparently the ice wall is south of the South Pole because I haven't found it yet. But you get somebody to go out there and say, yeah, this section of the pole is your birthday. So I usually get them to take a picture of that. So
do you want to give us a little biography as to who you are and what you do? That'd be really cool for the audience.
A planetary scientist. There's a specialty of astronomy. They call us nearsighted astronomers because most of the planets that we know about are within like 1,000 light years or so. And then I suppose the cosmologists that deal with things, way far back in time and way far out. And so I'm a scientist. I also do a lot of work in computational number theory, which is a special way of saying using computers to perform and to engage in mathematics. So number theory is kind of a specialty form of mathematics, and computation is a special form of number theory. So I often use computers as tools to explore the world of mathematics. I'm also involved in cryptography, which is sort of another interesting form of mathematics, and also a little bit on computer security. But primarily, I'm an astronomer, and as a planetary scientist, I study the inner parts of solar systems, like where Earth is. So Earth is one of the planets I get to study because it's right here and convenient, and but there's other planets also that are here and fortunately, with the development of better detectors, we've now have quite a number of planets that have been doubly confirmed outside of Earth. It used to be, our set of 9, and yes, Pluto's a planet. And now we have 4,281.
That was going to be my first question.
4,281 known planets there. Now, there is a definition, what's called a geophysical definition of a planet, and something that Alan Stern was co-author on a paper, and basically it describes what a planet is as opposed to where it is. Some people say it's not a planet unless blah blah blah. In fact, the current silly definition that the IAU puts out has a really parochial definition, which says it's got to be one of these things that orbit our star. So they didn't even recognize planets around other stars. They're that myopic.
Exoplanets,
but
yeah.
Pluto is classified as a dwarf planet, and nothing wrong with being a dwarf. Just as dwarf stars are stars, and
That's
dwarf
right,
galaxies
right.
are galaxies.
I knew it. I knew someone was going to make a joke about me being.
So Pluto being a dwarf planet is just a description, just like a gas planet or a rocky planet or icy planet. Or whatever it is. It's a description, right? So Pluto. That's why you say, well, why is Pluto a planet? Well, it's a type of planet called dwarf planet. It turns out, based upon the sample of 4,000 some odd planets in sort of surveying the nearby area, they also do about 1,000 light years or so. It turns out that dwarf planets are usually they're actually in the majority. The rocky planets seem to. Go ahead.
Why did the definition change? Because it was only quite recently that it was changed.
It's sort of a question of whether it changed or not. They were trying to get a proposal to get actual formal definition of a planet. And it was made the proposal was made, and a bunch of people who are called orbital dynamicists, or people that study orbits of things, objected to Pluto being classified, and then did this little vote where at the end of the session, where most people had were out on the town and skipped things a couple hundred, instead of thousands of people in the hall, there was a couple hundred people in the hall. They just said, "Hey, let's cook up this definition," and the press kind of ran with it. But planetary scientists really don't use that definition. Don't really pay attention, in fact, to that system. In fact, they ran into trouble because the way they defined it, Earth, Jupiter, and Neptune were in danger of losing their planet status, and they made some tweaks to it, but they found it just too controversial. So, by the way, Pluto doesn't care whether you.
Why would they try to get rid of Neptune?
Well, you see, the people that did this, we don't want Pluto to be a planet. Put a definition that says it's got to be dominant in its orbit. And for example, Earth has this big honking thing out there called the moon. And in fact, it's the balance point between Earth and the moon is just underneath the surface of Earth, right? It's a fairly chunky size thing relative to Earth. And so we said, hey, Earth hasn't cleared its orbit because it's got this big moon thing out there. Jupiter and Neptune have these piles of asteroids that are about 60 degrees in front of and behind in their orbit. The Jupiter is called the Trojans. And in the case of Jupiter, there's tens of thousands of asteroids that kind of go along Jupiter's orbit, 6 degrees ahead of and 6 degrees behind in its orbit. And so we say, hey, it may be the biggest planet in our solar system, but it hasn't cleared out the stuff ahead and behind it. And
are those in like Lagrangian points that they're just kind of stuck there?
Yes.
Yeah.
Yes. Or they drift towards there. So technically what happens is that they're being pulled along or influenced by Jupiter's gravity. And Neptune has a similar system like that. So we were playing basic games with them, saying, hey, if you insist on your silly definition that it has to orbit our star and nowhere else in the universe, and it's got to be dominant in its orbit, but it's got all these other things in its orbit, then we'll just get rid of Neptune and Earth and Jupiter in the planet category, and you can live with that. They didn't really like that sort of thing, so they tried to make some definitions. But we're now there's a geophysical definition that gives our solar system 115 objects that we call planets. You say, 115? What's that? Well,
oh man, that's a long acronym.
Yes, and that was, in fact, that was one of the
every single one in order.
That was one of the silly things that the IOU, again, they're really silly. They are a really silly, ridiculous organization. But one of the things that the IOU secretary said was, well, we can't have too many planets because it'd be too hard for children to memorize it. And so I came back and said, we have too many elements, so we'll just go back with earth, fire, water, air, because people can memorize that. This 118 elements. That's just, it's tough enough for King Lear to or Lauren Lear to make a song about it. The elements, right? But
my very excellent mother just served us 9 pizzas on top of Old Smoky, all covered with cheese. It'd just be the longest thing. Hey,
yeah, it would be, yeah. So, but really, it's about this, right? Is something a planet because of where it is or what it is? That's really the thing. And if IOU followed the rules, they would say there's not a scientific consensus. IOU is not supposed to declare science. It's supposed to describe what is being decided. And given that there isn't a decision, it should have remained silent. But instead, it remains silly, and so it deserves its ridicule that it gets. So back to say, is a planet because it orbits our sun? Well, you might say, well, that is not a reasonable definition. Well, but our sun is one of somewhere around 200 billion stars in our galaxy. So to say it has to go by our sun, if it doesn't, our sun is not a planet. That's I think that's a bit parochial. Also,
so I have a question.
Sure, please.
When speaking about the size, excuse me,
Cool.
horrible start. But when speaking about the size of these planets and where they're at, I've always been someone that's looked at the size of Jupiter's moons, and Jupiter has at least 4 moons that are planet size, if you ask me.
Yeah, they're quite. Jupiter, you're right. Jupiter has some very the so-called Galilean moons,
Ganymede and Io,
Callisto, and Europa, and those moons are actually dominant in Jupiter's system. If you took the mass of those 4 moons and you looked at the 5th moon, the 5th biggest moon that's orbiting Jupiter, it's 1/8,000th the mass of the smallest Galilean moon, right? So they really dominate that system outside of Jupiter. And,
well,
and you're right,
they're much bigger than Pluto.
And so the question is that does size matter? And we really think of basically is that like, well, no, it's not where an object is, but what object is. For example, it's possible for planets to be ejected from their solar system. You get an encounter where 2 kind of almost collide, and one gets slingshot out, and one dies in. And the question becomes, well, if it gets ejected, we call it a rogue planet. Does it cease to become a planet because it's not orbiting its star? So let's say if you say, okay, IU orbiting our sun, that's kind of a mistake. Let's say orbiting a star. Well, then you have problems because we have found planets free floating, not orbiting anyone's star.
Has anyone claimed them yet? Because I'd like one of those. Just out there doing its own thing. I will self-fund a rocket to go catch up to it.
Yeah, okay, but well, you're welcome to it. They're maybe hard to get to it, but
should have gotten that Tesla that was fired off into space. You could have gone and get it.
I could have drove it right over there.
Exactly. What's wrong with you? Put a big solar sail up. You'd have been there in no time.
So here is a very simple definition that the geophysical definition has. It says a planet is a substellar mass body that has never undergone nuclear fusion and has sufficient self-gravitation to assume a spherical shape adequately described by a triaxial ellipsoid, regardless of its orbital parameters. Now, what does that mean? Well, substellar means it's not big enough to become a star, to have fusion going on, crushing in its core, right? So if it's a fuser, then it's not a planet. It's a stellar body.
If Jupiter
and has enough.
If Jupiter was like, what is it, like 5 times bigger, it would be like a brown dwarf.
I think the number. I mean, the number is debated. It's somewhere between 17 times bigger and 70. Is somewhere in the brown dwarf thing, and it probably has to depend upon how dirty the fuel is, right? It's possible.
Consider Jupiter a failed star. That's what we always learned.
It failed to become a failed star, right? It's got like an order of magnitude too small to get anywhere near even being a fuser. But
is very similar to our star. So
and for good reason, if our model of how our solar system formed is reasonably correct, then the collapse of a gas cloud caused by 2 stars 4.8 billion years ago, and the second one 4.7 billion years ago, that went supernova, went bang, and the shock waves went out, hit this gas cloud that the sun was part of, and one of the little nodules got a little bit dense, and because of that extra push, and it had gravitational pull, it started piling things together and piled up, and in the core center is where our sun was. It was a system like the Pleiades. That's that Subaru, or the Japanese call Subaru. That's a little constellation up there, a little tight group of stars, open cluster. And one of the things that's being worked on right now is to try to figure out the siblings of our star. It's unlikely that our star was a singleton little tiny spot that grew. It probably was a open cluster of stars. And one of the reasons for finding our stars' siblings is that they should have similar age, similar composition, and perhaps if they are good enough to make Earth here, they might have to have other sorts of stuff out there, because the two supernovae that seeded it, first one started to collapse, and it was about 100 million years of it going into a dense nodule, and the second blast came through, and particularly a lot of that stuff stuck, because now we had this semi-dense lump that could catch lots of material. So we got a good chunk of rocky bits in their in METs.
So how do we figure out our star's siblings from within? Because obviously, when we're looking at galaxies that are far away, we can see the pattern. But once you're inside the pattern, you can't see the pattern essentially, because you're looking out the window.
You made a good point, because the study of our galaxy and trying to get the shape of our galaxy has been difficult being inside, right? We can look at Andromeda out there and see it, but we can't come outside of our galaxy because it's too big for our current technology. So instead, we map it from within. In fact, there is a very important mission called Gaia, Gaia. It's a super star mapper, and it is going to, it's mapped about 1% of the luminous objects in our galaxy. It has given us, for the first time, very accurate positions of several billion stars. And not only the position, but their velocity, because it's basically, it's out in space, out in one of the launch points, continually scanning the entire sky or sphere, and it notes positions of stars, and then it's been doing it several times. We can actually see the stars moving, because they're slowly moving inside our galaxy, and it's able to identify not only positions but velocities and wobbles. And so now we have actually a fairly decent internal map of objects. Now, there's some blind spots. We have these gas clouds that we can't visually see. And so we're going to need to do an infrared scanner, because infrared can peer through the fog that some of those gas clouds are. It's kind of unfortunate. Our center of our galaxy, the Milky Way, is blocked by some pretty fantastic gas clouds. And so we don't see the big central bulge. We don't see, because it should sort of look sort of like a flying saucer, the central bulge and arms coming out. But instead, there's this big blob kind of in front. So when you go out to a place where you can really see the Milky Way really well, particularly if you go into the southern hemisphere, where the center of a galaxy can be straight overhead, you can see really obvious the spiral arms go across, and you can start to see this extent of this cloud, because you can see a little bit of the fringes of the Milky Way, kind of the bulge going around it. It's one of the reasons why you should go to the southern hemisphere. To see that.
So
sort of thing. And
road trip.
Is that effective? Still like looking at the behavior of other galaxies and then using that to model what we know and filling in the blanks of the places.
That's one of the things. And then we can look at similarities. Look at. We now know distances within our galaxy and velocity positions. So we now have kind of this thing. And in our galaxy is one of the spiral galaxies called a bar spiral. In the center is this, besides this lump, there's this bar of matter. It's not a completely, because it's spinning around, it's like the lump has kind of stretched a little bit. And then from those bars, we have spirals that are coming out, because they're kind of wrapping around and also being influenced by dark matter and so forth. So we have and then we can see many other galaxies that are spirals that are in the universe, so we can see what it looks like from the side, from far away plus inside. And that's given us this notion that our galaxy, having about 200 billion stars, given this, that we've been able to detect planets with some effort out to about only 1,000 light years, where it's It's the galaxy is about 100,000 light years across on that scale. 1,000 light years is not that big, but it's enough stars that we can get a valid statistical sample. That's why we have the current confirmed count with 2 independent methods is 4,281 planets. What that means is that in our galaxy of about 200 billion stars, there are at least 1 trillion planets. That is, there are more planets than stars. And typically, the singleton stars like our sun, about 70% of them have planets, at least. Right? And of the multiple stars like binary star systems, about 30% of those have planets. And it turns out that rocky planets are the majority, not the gas bag Jupiter like Jupiter, Saturn, Uranus, Neptune. It's the rocky planets like Mercury, Venus, Earth, Mars, Pluto that are the majority. And it turns out that it's Pluto, its dwarf planets are actually the majority of planets are on that side. So back to that, finishing with that definition, it says a planet is paraphrasing, saying a planet is not something that's a star. It hasn't undergone fusion. It hasn't even undergone failed fusion. It's not, as you said, it's not even a failed star. It's never even tried. And it has enough gravity to store itself into a roughly sort of roundish shape. So it means that a body like Phobos, just this rock out there with crags and sticky points out there, is not a planet. But the moon, our moon would fit the definition. The 4 Galilean moons are definition. There's roughly 110 known planets in our solar system that fit the definition, right? And even things like Ceres, right? That was because part of the definition came about where they were seeing these orbital zones, and they figured, well, there should be some orbital zone between Mars and Jupiter, and they found Ceres, right? And they said, we found that missing planet there. And then they found Vesta and Juno and so forth. They found a bunch of other things, and they said, oh, wait a minute. Why is it all this stuff? And then they basically determined that these things are relatively small and declared them as asteroids. So they're not, they decided there weren't planets. So at one time we had 11, 13 planets, and we dropped down. So this definition basically says, round objects in space that are smaller than stars. That's the definition of planet, is a round object in space that's smaller than a star. I mean, even somebody in elementary school could understand. It's not a shiny thing by itself, and it's round. Therefore, it's a planet. And it doesn't matter if it's orbiting a star or not. It doesn't matter if it's orbiting something else. If it's a round object that's not that's smaller than a star, it's a planet.
You're in there.
So it's what it is, not where it is.
To sum up.
So I did have to ask this as well.
Both planets matter.
Yes, absolutely.
You matter. I mean, they matter, Wayne.
So later on in the show, I did want to talk a little bit about Antarctica, but since we're on the subject of the asteroid belt, what do you think caused the asteroid belt to be there? Is it a blown up planet, or is it?
I mean, and that's been a very people wondered about that ever since we knew that there were multiple objects inside the zone between Mars and Jupiter. Solar systems have roughly circular orbits, get these zones. And the reason why they get these zones is if you get a lump in that zone that becomes kind of dominant, then it gravitationally tracks other things nearby. It sweeps, and as it goes around the star, it kind of sweeps around, and any smaller objects get drawn to it, impact, and you build up this sort of almost like this dust bunny going around the star, picking up and sweeping out stuff. And it can only, as things get farther and farther away, it gets harder and harder to pull it in. So it ends up clearing out a lane, if you will, around the star. Now, Jupiter was the big heavyweight. It is a big heavyweight in our solar system. If you ignore the sun, Jupiter is about 78% of the mass of everything else that's gravitationally bound to the sun. Almost 4 out of 5 atoms that are not in our sun, that are orbiting our sun, are in Jupiter, right? So it's got the big dominant thing. Saturn is about 11%, and the rest of the planets are kind of rounding errors, right? So it really is dominated by Jupiter and Saturn. Now, why Jupiter? Well, if our model of how our solar system formed is reasonably correct, then when the sun finally fusion really started going strong, right? If you think of it, it switched on, right? It started fusing. That fusion, that nuclear explosion pushed out. Popped a bubble. Remember, the edge of the sun is defined as stuff that is gravitationally bound to it. If you're farther away from the sun, the radiation pressure pushes you out. You're not part of the sun. If you're stuck into the sun, you're part of the sun. So when the sun's light switched on, it popped a bubble in this gas that was collapsing. That bubble edge is where Jupiter formed. So all that light gas, all that hydrogen, helium that was loosely bound but not close enough to be stuck into the sun, got popped out. And Jupiter began sweeping up that edge of that bubble. Now, the heavier, denser materials like iron, silicon, magnesium, all the stuff that's sort of terrestrial like our Earth, wasn't pushed out as much as the lighter gases. And so that's why you have 4 rocky planets inside. But what about that zone? What about that asteroid? Why isn't there a big planet there, as opposed to things like Sirius, which is a planet according to their definition? The reason is Jupiter. Jupiter ripped it off. I mean, Jupiter being so massive, it started drawing in material from either side. It pulled off so much material from that zone that it was never able to accrete and form a lump. Even Mars is relatively anemic as far as planets go. It's a relatively light planet. If you look at the density of Mars, it's actually relatively light. It's also a small planet, almost dwarf-like. It's kind of dwarf planets. Kind of there's a vague definition, but Mars barely makes it's not a dwarf thing, because Jupiter was such massive, it's gravitationally cold material that Mars became quite anemic. That's unfortunate for Mars, because the reason why Mars doesn't have an atmosphere is it lost it. It doesn't have the gravity to hold on to the gas. So whatever early atmosphere that formed when it had oceans and other stuff licked away. The temperatures on Mars, temperature is a function of motion, right? It's how fast atoms are moving around. And in the case of Mars, things like oxygen at Mars temperatures achieves gas velocity. It launches itself into space. And so Mars doesn't have a nice atmosphere because it lost it, because it doesn't have the mass. It doesn't have the mass. Why? Because Jupiter ripped it off.
Thanks, Jupiter.
Whatever. And it barely escaped being a dwarf planet. That whole so-called asteroid belt, never got much more than, it was barely able to make one dwarf planet called Ceres. So, blame it on Jupiter.
So this whole theory of terraforming Mars by melting the polar ice caps is all nonsense. Because as soon as you do that, you're going to be repeating the same process. Because if it hasn't got the atmosphere, everything's again.
There's a reason why Mars doesn't have an atmosphere, because it can't hold on to it, right? So this notion of you can somehow make a bunch of atmosphere and then it'll be temporary and then it'll leak away, right? Now, given what we've been seeing by the rovers, we know that Mars had enough of an atmosphere that water could stay around for maybe 100 million, 200 million years, something like that order. So it wouldn't go away instantaneously, but there's a reason why Mars doesn't have an atmosphere, because it can't hold on to it. So you're better off, by the way, not trying to terraform the surface. You're better off going underground.
Yeah.
And one of the reasons is Mars doesn't also have an ozone layer. So all that radiation from the sun directly hits the surface and really makes it kind of not friendly to complex chemistry like life.
So when the sun,
you want to be underground on Mars.
So when the sun expands, what's our exit strategy? Where can we go in our solar system? We gotta
You're gonna be dead.
We gotta us as the human species. Like, so where could we go to run away from Big Bad Sun, who's about to like have a serious bloating incident and wreck our poor little planet?
Yeah. Now that bloating incident is about 6 billion. The big part of the bloating incident is about 6 billion years, but in 1 billion to 2 billion years, when the sun starts to get a little bit middle-aged pudginess, things are going to not be so comfortable on Earth. And so we need to move out from the sun, but not either. You either have to leave our solar system altogether and find another star, or you have to be mobile, because you can sit there and say, well, maybe objects in the asteroid belt like Ceres might still be comfortable, because we think when the sun goes into its maximum giant phase, its orbit will about reach Earth's orbit, right? It's debated whether Earth would be drawn inside the sun or just right next to it, but that Earth will be toast. So you got to get off Earth, and you say, well, is Mars good enough? Or you have to go out to Ceres. The big thing you got to do is we have to be able to develop spacecraft that are independent of Earth. So far, all of the spacecraft that we've had that have people on it, or critters like dogs and so forth, have been dependent upon Earth. We've been tethered to Earth. When we went to the moon, the Apollo astronauts basically carried this capsule of air, water, food, and waste perception, and basically were able to hold their breath long enough and come back, if you will.
Right.
But they couldn't stay on the moon because they didn't have the resources to keep going. We'd have to keep supplying them with stuff. So the International Space Station only operates because we keep having to send stuff up there to give it new food, water, and take away the waste, right? We have to, and to do that to Mars it's hard enough to get robots to Mars. To continue to supply the stuff back and forth is really a inefficient way. So what you need to be able to do is to start off with terrariums. You know, those little glass bowls you have where you have a bunch of moss and critters and so forth, and try to build your own little ecosystem. The proposal is to start with a simple spacecraft that orbits at Earth sun distance, but not at Earth, and it's got to be self-sustaining. So you got to put enough stuff there to have a biosphere and biocycles where you don't have to keep supplying with food, water. It's got all its stuff to do its thing, right? And to experiment those things in a serious way, because if you're going to send a spacecraft out to the other stars, you're talking about long journeys. I mean, given our technologies, some of the best technologies, you're talking about, multi-generational type systems. You can't keep sending stuff from Earth to this spacecraft to keep it alive. It's got to be able to operate on its own.
You're basically explaining the second law of thermodynamics. Yeah, we need to break that. We need to work out how to get past that, because obviously with an isolated system, you have to keep putting energy into it, and if you can't do that, it's not sustainable in any way, shape, or form. So we need to figure out a way of breaking the laws of thermodynamics.
Breaking the laws, but we need to be able to understand biosystems. That's why astrobiology is actually an ongoing field of people trying to understand biological systems that are not Earth. And so you've got to have a spacecraft or a station which is self-sustaining, has enough bio life cycles, waste, and recycling to be sustainable. You got to be, that's the ultimate in recyclability, is having a spacecraft where you can survive. Now, there are other problems that we have learned from being on this International Space Station that we're making good progress on. One of the ones we've made the best progress on is bone loss, right? We've determined from people that were doing these long space flights up year plus that in weightlessness that they start to lose their bone mass to the point where they would if you had a 2-year long journey and didn't do anything, by the time you went and landed on Mars with its weak gravity, you would break your legs just standing up. So there's now regimes to try to keep you from having that bone loss problem. But there's other problems that we find as well.
Because your body's super efficient. It's like, we don't need all this extra calcium. You don't even need it right now. So I'm going to get rid of it. Don't worry. I got rid of all the extra calcium that you weren't using.
Yes. And bone loss has lots of other problems too, just besides being brittle bones. It's also where bone marrow is. It's an important part of our body. But we've also learned that your eyes have problems. The people who go on this for long space flights, the weightless, get macular degeneration. The retina starts to degenerate. Some ways it starts to detach inside. Ooh. Now, this has been very exciting for medical research because generally causing retinal degeneration in people is considered unethical. But if it goes up into the space station to begin to have these things, they can study it, and then developing therapies to try to arrest that and to stop that process. But our eyes evolved with 1G in mind,
right? And
0G, they're just not quite.
So I'm hearing metal legs and the visor from Jordy.
Yeah, there you go. Now, there's another problem too, is that we see that people start to have brain degeneration, early onsets of what sort of mimics Alzheimer's. This has also been quite exciting because that's something they can study as opposed to trying to induce Alzheimer's in people.
That's exciting.
and so therapies are being developed in that regard to understand there. There's also a issue of radiation, right? Our Earth and our magnetic field gives a nice magnetic bubble that protects us from a lot of radiation from the sun. Even when the sun, occasionally punches through and nice get auroras and so forth, these flares. There's a lot of radiation when you leave our nice magnetic bubble that our Earth makes. And so being exposed to that radiation is something that we've got to deal with and try to mitigate. So you've got radiation, going senile, going blind, and having your legs break are things that we've learned. And so people sit there, well, why haven't just gone to the Mars, right? Isn't Elon Musk? Well, I'll point out, Elon Musk said he'd be there by now anyway. So he kind of bloviated.
Just go on holiday and be done with it. Just go on holiday.
So baby involved,
I'm not saying these are impossible, but these are things we've learned on International Space Station, and we are making great progress as part of their experiments that they're doing, and why they also put in like spiders and other critters and mites up there to study this stuff, to understand, because this is going to be necessary for a long space flight. Be able to handle it. So you need a ecosystem that's self-sustaining, that doesn't get wacko stuff happening. You don't want to have some virus like COVID-19 going through your space station and losing stuff.
We would
you
all
don't
wear
want to have
masks.
some mold. There you go. or some would and some wouldn't, depending on their.
Yeah, they just be like, you know what? I have a space right to just cough everywhere in 0G.
Yeah, you could do that.
That cuts out my oxygen.
You could do that in another spacecraft. So, but these ecosystems, you don't have a super mold that just goes and destroys your crop,
right,
or sucks up all the oxygen or something like that. So understanding these ecosystems has a lot of benefits here on Earth as well, in terms of understanding life cycles and biocycles.
Can we just put a solar sail on Earth and just take it with us?
There you go. So the possibility of how right now with our technology that we understand now, how would you get to a place like our nearest star besides our sun? To do Proxima Centauri, Alpha Centauri, one of those nearby stars, would require a multi-generational thousands, if not tens of thousands of years.
It's like 50,000 years,
space.
right?
And they're trying to cut down that thing with exotic systems, but it's not going to be in, given our current technology, it's not going to be in our lifetime. It's not going to be a lifespan of humans. You got to have multi-generation. And we don't know actually how pregnancy handles in space.
Let's not talk about that right now. Jesus.
Yeah, there are rumors that people have tried reproduction in space, but we don't know about pregnancy.
Oh, what a mess!
That's a proper club, that, isn't it? That's a proper club.
Just
Yeah, that's more than the kilometer high club. That's the 100 kilometer high club. Yeah.
You just gotta wet wipe the entire capsule.
Club.
Every surface you have to wipe down, not just the floor. Everything's got to get wiped now.
Yeah, you need that. You need UV on the ceiling too.
Yeah, just everywhere.
But anyway, this is part of this problem there. But you wanted to talk more. You also brought up a thing you wanted to talk more about down here closer to Earth, which is probably the closest that normal humans can get to in outer space, which is visiting Antarctica.
Ears.
Ooh,
That other
yes.
land.
So
Wait a minute.
Antarctica is my favorite. Is my favorite non-populated continent on Earth.
Can we get an exclusive on the BIM podcast right now? Can you confirm, right, that the Earth is not flat?
The Earth is not flat. The Earth is lumpy. I might say
That's good
now.
enough.
I will say, as a little kid, I was asked, is the Earth round? And I said, the Earth is not round; it's lumpy. Because to me, round meant spherical,
Like a cue ball.
and sphere, and I could see mountains. So if I'd have had more of the language, I would say it's pretty close to spherical shape, but it's got lumps on it. So it's not a smooth burial ball. It's got,
Is it
pointy
an
bits.
ovoid?
Yeah, it's a sphere. Actually, it's more egg-like in its shape because the south part of the planet's more pointy than the north part. If it would look more egg-like thing. I mean, we're talking very slight, not to the degree that a chicken egg is, but it is for first approximation a sphere. Second approximation, it's a bulging sphere because the centrifugal forces has caused the equator to sort of fan out and the full poles to flatten. And the third thing is that the North Pole is flatter than the South Pole. We're talking about the geophysical pole rotation. Yeah, it is, and I have been to both the North Pole and the South Pole. I've been through all the longitudes things, and so I can tell you it's not a flat pancake. It's not a donut. It is roughly spherical, and it's pretty big. Let's say it takes a while to get down there.
Canby Island.
So my next question, since we're talking about Antarctica, was the possibility of a ancient Antarctican rainforest.
Yes, actually, one of my real fond memories in Antarctica was standing on a fossilized bed. We were up and around 4,000 meters elevation, so that's in feet, roughly 13,000 feet. Antarctica has the highest average altitude of any continent, so it's a high altitude place. But we're up there on one of these ridge lines that were tall enough to peek up above the ice. And I was standing on this fossilized seabed. You could see the ripples in the sand, and you could see trilobite trails going through the sand of critters to where it was once this nice inland sea. I've seen other fossilized creatures there that are marine like, And so, given our model of Pangea, Gondwana, and how it broke up, we know that Antarctica went into the deep freeze only about 2 million years ago. That's when the Southern Ocean became circumpolar. That is, beforehand, Antarctica was kind of glued into bits of South America that kind of stretched together and had this long kind of ridge line. But once it pulled away and you had this continuous ocean, then you created climate conditions where it went into deep freeze. And so its ice that it has on it is roughly dates back to about 2 million years of being icy. And the oldest ice we have is roughly around, that we've drilled into, is roughly around 800,000 years. So there are lakes underneath the ice, very large lakes that are biologically active, that have been sort of sealed off from the biosphere for at least 800,000 years, probably close to somewhere around 1.5 million years, because it didn't freeze over instantaneously. It took a while for it to build up. So for those people that live in, and so for those people that live in snow country, if you don't, shovel your ice and driveway, you get that ice buildup. But you do that for about 1.5 million years, even if it's a desert, which Antarctica is, you get fairly thick ice.
What's that area of the South Sea called? That's like between, what is that, the tip of Chile? That most people would like for ships and stuff that used to go down there. Like that area of sea there, of the South Sea. Wasn't there like a name for that? Like a...
Well, are you talking about the Magellan Straits? Is that little little shortcut?
It had like a nickname because of the waves and all of that stuff. I can't remember what it was.
Well, it's called, they call it the Roaring Forties, the insane 60s. Well, yeah, I mean, one of the also the fact that it takes a long time to go around South America and back around, right? Whereas cutting straight through was more efficient. Now with the way that the sea ice is changing, and climate is being forced, the northern passage through Canada is now becoming viable. There are now periods of time where icebreakers can make the way through the north part. And that would be good for Asia, going through the Bering Straits, going basically hugging the edges of North America, cutting through Canada and reaching Europe. And of course, Canada is basically saying, hey, wait a minute. It's our place, A. And by the way, happy Canada Day was Canada Day yesterday.
Happy belated, you Canadienses.
Yes.
Can I ask a question that might not be in your wheelhouse? Because I work in renewables and energy efficiency and stuff.
Very good.
I'm just wondering, where do you see the future of energy consumption with regards to how we're going to generate, what's viable, and what's sustainable? Because
multimodal is the key. I think if someone sits there and says, you should all build blah because blah will answer all of our problems. Different energy sources have different benefits, different problems. Nothing's for free. They have different efficiencies. And so in order to have a really good power grid and a collection of energy systems, you need to have a mixture. You want to minimize the ones that have particularly bad side effects and maximize the ones. But notion of just saying, oh, we just use tidal power and that's it. Or we just do solar, that's it. You need to have a combination of systems to be, I think, have a reliable, redundant power system that has a distribution of features. And you need to be, the more long term it is, I think, the better for systems. So
my theory is you need something that all works in symbiosis, in the sense of you need something that can utilize carbon capture, use solar, use tidal, use all these different things, that the byproduct of one will fuel another. So you have this, as I say, the symbiosis of,
And that's
of
somewhat,
energy.
you know, talk about of the ecosystem you have on a spacecraft, right? You need to have that sort of system,
Yeah.
those systems going.
Yeah.
And in case of energy as well, that those side effects you can't prevent, you need to be able to mitigate. And so, and those you can't mitigate, you need to be able to detect and hopefully correct or minimize that use. And that becomes a sustainable thing. But someone to say this one thing and everything is from it, it's putting your eggs into one basket. And again, so something like solar that has the storage problem can be solved, but even the storage problem is multiple. It's not just saying the answer to solar is batteries, right? You have things like in Australia, allegedly, where you have to say allegedly because, there are people that claim it doesn't exist. And you say allegedly.
You'll have Thunderfoot all over us.
Otherwise, Susan will ban you from her platform. So you can use systems in something like solar to pump water uphill and then let the water drain down, and so you have the combination hybrid of let's say solar and hydro, where you can generate excess solar when the sun shines. Use that excess solar to pump water up to a reservoir. Use the reservoir for crops and other things, and let the water come down and drive turbines to drive stuff at night. That's an example of this kind of hybrid system that they're doing very successfully in Australia. But again, tidal, wind, and even nuclear are things that you should also consider as part of your portfolio.
And also, thoughts and prayers. Let's not forget about thoughts and prayers as a renewable source of energy, healing, and just general merriment.
Chi and aura, I guess, is the chakra thing. But that's one of those things that for sending a spacecraft outside of our solar system, even getting to the point of out into Jupiter type orbits. You're so far away from the sun that solar doesn't work. The sun gets weaker and weaker and weaker, right? It's hard enough to get solar on Mars, but it's doable. At the asteroid belt, it becomes pretty weak. And by Jupiter, forget it. You have to have a different source. You can't use sunlight effectively at that distance. And if you're going to go to the stars, you're going to spend a lot of time in places where there's a star. So you need to have a fuel source on your long-term spacecraft that's going to sustain for a long time, and that's also a difficult problem. But probably right now the best we can understand would be some form of nuclear power source. So again, it's a mix of things. At least they have their pluses and minuses. Minimize the minuses. Enhance the pluses and have them be the combination to build a robust system.
So even though you're in an atmospheric space, the vacuum, photovoltaic energy is increased by being in space.
Being far away from the sun, right? When you go to twice the distance of Earth, Sun, 2 AU, the sun is now 4 times weaker.
It's a quarter, yeah.
Because it's a quarter, right? So when you go to 10 times the distance from Earth, the sun is 100 times weaker. Now you could make bigger and bigger and bigger solar cells that are less and less efficient, but pretty soon you have these multi-kilometer solar panels just trying to power a flashlight. It gets weak. And you say, well, how do you know? Well, at night, the stars up there, which are really far away, aren't going to do you much good. Yes, you could build a huge solar farm and get a few little electrons because you get a little bit of light there. And the moon comes around, it's pretty good, but only if the moon's around. But that's only if you're near the moon. Once you get away from the moon, it's a pretty tiny dot, not going to help you. So you need to have a different means of energy in the system. Plants are going to, if you have plants on your spacecraft, which is probably a good idea, because all the cool life cycle stuff and oxygen, carbon dioxide cycling.
And Groot.
those planets will need light to photosynthesize, and that light isn't because the sun becomes by the time you get out to Pluto, it's a bright star in the sky, but it's not very warm. It's not very energetic.
So basically, we're trapped. That's what you're saying. We're trapped. We're staying here. We're done.
Give up on all space travel. We're done.
So when the sun goes into giant phase, you can step back a bit.
We're never gonna
But the
make
problem
it.
is after the sun
What?
after the sun finishes giant phase and shrinks, it'll turn into a white dwarf. So the sun, we think, given stars of our sun's mass, have, and it's around 4.5 billion years, 4.6 billion years, roughly. Our sun probably has around 10.5 billion years left of shining. By the time it gets into the white dwarf phase, it's just this kind of this warm ember that doesn't glow very well. So if you want to escape beyond the next 6.5 billion years, you're going to need to find a different star because our sun's only got about 6.5 billion years left. So even if you move back a little bit while the sun blows up, that is not going to only keep you temporarily, because when the sun finishes that phase and shrinks down to a white dwarf, not a black hole, but just basically a glowing ember, it goes dark and it can come back. So
perhaps we can ride the wave of the expansion, and we got all the sails ready. We're just sitting there like, come on, like you're paddling out. Then the wave comes, and then we just ride that bad boy out of here.
yeah, indeed, people talk about light sails, of using light pressure to literally push a sail. The photons exert a momentum, and strike there. And you say, well, but doesn't it get weaker and weaker as you get farther to the sun? Yes, but then you can use a laser to point at it and kind of push it for a while. And then you just have to get it. You have to get it moving fast and let its momentum carry it forward.
So couldn't essentially, for a light sail, couldn't you essentially just sit on the back of the space buccaneer ship, sit on the back and just lean on your back and just point a laser at it and just propel yourself?
But if your point is trying to get someplace else, because you sit there and say, yeah, being out in cold dark space is not so fun, I want to go to another star.
Right.
And so you say you don't want to spend tens of thousands or hundreds of thousands of years. You want to shorten that thing. The next problem is you got to slow down, right? Yes, you get a laser to start accelerating you out really good, but you got to stop. If you don't want to just splat on the other side, you got to put the brakes, right?
Coming in
and
hot.
So you got to have another energy system to slow down, right? And that's another problem that people. So some of the early, things like these sort of starshot type lineal stuff. There was this very interesting Russian entrepreneur that's spending money. Seriously, not like stupid stunts that Elon Musk does, but real science to try and talk about saying, okay, let's start launching probes to nearby stars and have them send back data. And he said, we'll just be happy with taking this probe that maybe goes by Alpha Centauri and takes pictures and relays us back. Then we'll get 4.3 years before the signal comes back. But Delta technology to start sending those probes out there now. Yeah. And as the technology gets better, they'll get shorter and shorter and shorter times for getting up there and back. But he really wants to push this notion of being able to reach the stars.
But that
sorry, Mikey. I watched this documentary years ago. I think it's like 1984, where all you need is a spacecraft, and you can fly around the sun, and you can fling yourself back in time to 1984, and you can just relive your life again. It's fine. They've got whales and everything.
Yeah. I mean, it's. I mean, you do get time dilation, but time dilation just means that relative to other people's clocks, your clock runs slower. But to you, your lifetime, you're what? You're going to have 60 years left, 70 years left.
It's optimistic.
And even I'm trying to be generous, right? Even if you're
Cheers,
in
mate.
some,
You can come again.
Have you seen how much Shiraz this bloke puts down? I don't know if 70 is
Excuse me. You're fine. I'm on the Chateau Neuf de
Gonna
Pape
be
tonight.
2
Ah,
kids. His
excellent.
life is shortened.
excellent on there. Well, I'm doing Bootleggers Hill here,
Oh,
so
there we
that's my. From,
See,
from Costa Brown.
Landon, what you don't know is we have a regular feature. We have a regular feature of what are we drinking, and we've just kind of done it by accident. So,
Yeah.
Brenna, what are you drinking?
I actually finished my second cup of coffee today.
Mikey?
I am having Coca-Cola plus ice.
Okay.
Rum?
What's that?
I am also having a chilled Coca-Cola.
Ooh.
My man.
Oh.
There we go. That's
Ah.
this.
That's the
Yes,
ticket.
let's do this seriously. So Costa Brown is an amazing winery, and
Some people can day drink. I can't.
It's
well,
easy.
you just have to have the right time zone, right? So this is Russian River Valley, Sonoma County. Bootleggers Hill is the name of the wine from Costa Brown, 2015 Pinot Noir. So cheers.
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 All
Well, my Chateau Neuf de Pape is a 2014. It was
Excellent.
brought to me by the in-laws today for my birthday.
Ooh.
It's my birthday.
Oh,
And
it's
yeah,
So-
I'm really enjoying it.
so as I say, it's getting there and slowing down and sort of thing. So these star shot things that's being done, has some serious people doing serious science behind it. And I mean, it's not like I impugned Musk, but two things that I am disappointed with him in. One was to waste mass having a launch vehicle that's now in solar orbit with a stupid car, right? There are many things that you could take from that mass and put something on it, like bioexperiments, like telescopes, other things. But to stick a car out there is kind of weird.
100% agree with you. It goes back to just because you can doesn't mean you should.
Can I
Yes.
guess what the second thing is?
Yes, please.
The name of his kid.
No. Your ability to go out, outside of the cities, look at the stars and see this glorious nighttime sky with the Milky Way and all this stuff is going to be ruined by his thousands of little base
Yeah.
transmitter things for his sort of
Like space
Wi-Fi
shuttle.
on steroid stuff. Tens of thousands of satellites that'll now be crawling the sky with these points. Moreover, those things will be deorbiting on a regular basis. You get these flares of stuff right the nighttime sky. And his thing is, I don't care. You should be putting telescopes in space. You shouldn't be looking from down here. You should look from up there, right? So Elon Musk, you're a space putz.
Ooh,
Sorry.
You heard it, Elon. If you want to come on next week and answer these charges, then feel free to hit us up on Twitter.
Yeah.
At Bin Podcast.
You get credit for doing the SpaceX stuff, but you don't get credit for what it's being primarily used for, which is to pollute the nighttime sky.
I was gonna say I was disappointed when you put a car in space, mostly because if I was a extraterrestrial entity, if they exist, and I see this, I'm like, yeah, they got to stay where they're at.
Yeah. Yeah. And yeah, you could say, okay, that car was his little thing. Fine, right? That's a waste opportunity. But that pales in comparison to him destroying your nighttime sky. I mean, literally, I'm reminding one of my alleged friends in Australia that this southern sky we're looking at, the glorious, go out of the lights out of the Gold Coast area and go out into the outback and see this glorious sky, see the center of the Milky Way going overhead and all
I
of
want to see that.
that marvelous set,
So
that's in peril.
I'm not letting
It's
that go.
gonna
You just said alleged friends. What's happened there? A bit of drama.
Oh, okay. I should say, a while ago, a very good friend of mine, Red Eye.
What's up, Red?
We had sort of this running joke where I would there's this extreme flat earthers that claim that Australia doesn't exist.
Yeah. The harness
Yeah.
people.
And so we had this running joke where I would sit there and say, yeah, the guy from a fake continent, we were using it in tongue in cheek. Apparently, so and I make these comments not on shows, but on like chat rooms, the video chat rooms. And so I would sit there and say, when Reddit comment, I would say, oh yes, here's the guy from the fake continent, that doesn't really exist, blah blah blah, ground harness, and we're making jokes about having to have ground harness to not fall off the earth, that sort of thing. Well, one of the little Susan minions looked at this joke set and said this could be potentially offensive to Australians. this joke, right? Now it gets worse because I have never uploaded content, right? I'm not a YouTube. I mean, I joined the club, but I'm not. What happened? If you're a YouTube creator and you say naughty, you get that community strike and they limit you for a time. But if you've never uploaded content, you can't be put on timeout. So what happens? You get permanently banned. So I have a lifetime ban from Susan et al. For making comments joking that Red Eye had to have a ground harness not fall off me, making sort of flat earth jokes.
Mm-hmm.
And so that's why now I say allegedly. And Red Eye knows this. So he's an alleged Australian, allegedly in there. And I allegedly went to visit him, and we allegedly went out to the nighttime sky. But the more serious thing is that, that sky that we were looking at is going to be filled with thousands of little spots moving around and flares of those things just orbiting. Your nighttime sky, your ability to go out and join the night sky is limited. Your ability to take a photo of something from the ground is limited. So there's going to be a lot of problems with terrestrial telescopes again, and Elon doesn't care. So that would be.
Do you think? Sorry, mate. Do you think that the whole flat Earth thing is Terry Pratchett's fault?
No, I think it's the fault of education systems. I think it's an example of a failed education system.
Because this world is pretty much flat Earth 101.
I mean, back in the Apollo era, someone doing flat Earth stuff would be put in a mental institution. Now with the internet and meme echo chambers, flat Earth stuff is there. Now, by the way, I don't debate flat earthers. It's hard to reason someone out of a position that didn't use reason to get into in the first place.
Exactly.
So while I know that there are certain channels and friends that do dumpster fire stuff,
Mm-hmm.
I prefer not to give them a platform. So instead I mock them. But you can't mock them openly because that becomes sensitivity, because we somehow seem to have this notion that you have the right not to be offended. Well, screw that right. So instead, I was making good-natured jokes to my thing. And by the way, Australia is my third favorite continent.
We invented that.
Yeah.
Oh, here we go.
Antarctica is my favorite non-populated continent. There's only at the summertime they may be close to like 500 to 1,000 people, and wintertime is around 100. Africa is my favorite populated continent by far. It's an amazing place and great diversity, and I highly recommend. I've been fortunate to go all over Africa,
Road trip,
north, south, east, west. I highly recommend it. And if it's not Africa, then I would go to Australia, because they're amazing people, amazing wildlife, and extraordinary skies. Best skies are in Antarctica. Second best are probably the Atacama Desert in Chile. Third would be probably Australia.
I really want to go to the Atacama Desert.
But
What's the observatory called in Hawaii?
There's a good set on top of Mauna Kea that is there, and so it's probably Hawaii is probably in the top 5 of spots in the world for there. It's pretty beneficial because it's only 17 degrees north, 7 to 18 degrees north, so you get a lot of the southern sky and the complete northern sky there.
And
so
they get very little light pollution as well. Is that right?
Yes, you're out in the middle of the Pacific Ocean, and it's nice pointy bits above the marine layer. It actually is a fantastic set. Similar to the Atacama Desert, high up, because you want it to be dry, because water vapor tends to clouds, and if it's not even clouds, it tends to interfere with other things like infrared and so forth. So you want dry stuff. So deserts are really good, and the top of Mauna Kea is effectively a desert. Australia is mostly desert. Antarctica is desert. The Great Atacama Desert in Chile is also a desert. Gobi is a great one. Sahara is another great one. I've observed, been around in Sahara as well. It has its issues. Every desert has its issues. Gobi, Lut, Saharan.
Yeah, no pubs.
No pubs. No pubs in the desert.
See.
Actually, it turns out in Sahara Desert, the people that bring the alcohol are essentially German and Italian people that come down from the cross Italian peninsula, and they sort of smuggle it in, or they get it from the embassies. So even though at the time we were there, Gaddafi, it was officially a dry country in more ways than one. Out in the desert, there was plenty of alcohol and other substances to be had.
Have rum, will travel.
Same thing. But talk about in Antarctica. So Antarctica is sort of administered by the Antarctic Treaty. It's a separate organization. It has nothing to do with the UN. It has all these countries that basically have said what happens 6 degrees south latitude down to the pole. The zone that really encompasses Antarctica. And so these countries that are part of it has said, whatever territorial claims we might have, we will put those claims in abeyance and let Antarctica be for the enrichment, the scientific and cultural enrichment of the planet. That's what it defines. So science and culture are considered, it's like an international park. And in fact, even at the South Pole Station, Edmondson Scott, arts are important. So they have a music room. They have several music rooms. One is dedicated to classical music. One's dedicated to jazz. Another's dedicated to rock, right? And they do artistic crafts and fairs. Pretty good people do overnight stuff. So if you want to be there, by overnight meaning you're 6 months over winter. So if you want to be more valuable person and can be considered for stationing at the South Pole, having some artistic talent is a plus.
I'm in there like swimwear, baby. I'm bringing all my acoustics.
You can join the the 300 Fahrenheit club, where you go to the sauna and heat up, and you can put on shoes, and basically there's a run of the sauna. You go outside the run, and you go out to the geophysical pole, you run around and come back in, and you get a 300 Fahrenheit difference and be members of that club.
Mate, I'm all about it. International Space Station Club. I don't want to go running around in the snow.
No. It is. I say, and living. So I spent a number of times, and what I do in Antarctica is I search for meteorites, rocks from outer space that are embedded in the ice. We have these ways we scan the ice, look for rocks that are just below the ice that are of course outside. And we found, I think I've in the times I've been there 8 times, we found like 21 meteorites in the ice and scanning. So I spent a lot of time on ice and not even at bases, right? Out camped on tents on the ice. and learning how to do stuff there is a thing. But
a tent on the ice just sounds awful.
When you step out of that plane onto the ice, you're basically in this bubble, right? This sort of 7-layer of stuff bubble, like this Michelin Man type thing.
I can't put my arms down.
And you've got goggles and face masks because you're under the ozone hole, right? That's where the big ozone hole is. So you're high altitude, dry, and very little ozone above you. So the ultraviolet light is extraordinarily strong. So you cannot expose skin. Even no matter how much melanin you have, that much radiation will damage your skin, will damage your eyes. So you have to be kind of covered.
You no COVID there.
No, and so you end up having to be in this bubble, and it's kind of like what I imagine stepping out in space is, right? You're surrounding, but unlike up here where if it's cold, I mean the algorithms that people even like Minnesota, they think, well, we know cold, right? There's something called a Minnesota syndrome down in Antarctica. People that think they understand cold and don't, right? And you can't tell them this is different. No, I'm from Minnesota. I know how to draw it. No,
Minnesota.
Sorry. So I mean, with all due respect,
is it colder than Europa?
It's not colder than. Is it colder than Europa? I think no. I think the coldest that the lowest temperature we've detected on the ground in Antarctica is minus 94 Celsius.
Oh God. Oh.
But typically when I'm there in the summertime, the temperatures are about minus 40 to minus 50 summertime. And by the way, what I would do instead is I would sit there and say, hey, it's 200 and we have 230 Kelvin to go around, right? Plenty of Kelvin. It sounds nicer if you because no Kelvin is
a way better.
Yeah, it sounds like you have more stuff, and so I've been there. The worst I've been there was 210 Kelvin. And by the way, it's not degrees Kelvin. Kelvin is its own. That's so. But
anytime anyone mentions Kelvin, I think of Star Trek.
Minus 160. Minus 160 for the temperature on Europa is minus 160 Celsius.
Yeah, so Antarctica doesn't get that way. It gets down to minus 94. That's been the thing, but not 160. Even so, there's a difference between experiencing outside cold and living in outside cold. Most of the time with people that are in cold climates, they have a house that's relatively comfortable, and they sit up in a coat and they go outside, get in their car, start it up, and they travel to a shopping center where they get out of the car, they go into the inside, and then they can take off their coats and be inside the shopping mall. They're basically taking a bubble and moving them from spot to spot, right? So your gear you have in a place like Calgary, or in a case like Minneapolis, is really designed to take a relatively nice home environment and translate it to a different nice environment. If, on the other hand, you are there for months, there you have to have a different method. Instead, what your gear does is slow down your heat loss, right? So the reason why you have multiple layers is you're trying to slow down losing heat. And when you're out there and this is a really big problem, you have to continuously monitor this stuff, because if, for example, you've got, you typically your hands are in 3 glove layers, and if your hand starts to get cold, you're in trouble, because you can't go to a fire and warm up. You can't go inside and warm it up, right? Uh-huh. You will, if you get behind the thermal curve, you better start doing some emerging things like, sticking in your armpit or trying to do something, because if it starts to get cold, it's very difficult to get it uncold. So instead, you try to minimize heat loss. But the other side of the coin is you've got to not get too warm. One of the other things that happens is sit there and say, well, I know how to handle cold. I just put on this big gallon suit thing and you're fine. And you find that those people who do that that don't need your advice start complaining about being cold. Why? Because they have too much gear on. Why would too much clothing make you cold? Because you sweat. And when you start to sweat, the perspiration moves out to the point of the freezing line. And then you get that turns into ice.
Yep.
That ice starts to transfer heat rapidly. And so when someone's complaining about being cold, sometimes you find they're wet. You got to get them into a safe environment and have them put on less clothing because they're cold, because they're too cold. So one thing you have to do is have layers. You can't just sit there and say, I can have some super bubble thing. No, you have to have layers of stuff. So what you have to do is you have to monitor your temperature. And when you're getting a little bit warm, a little more uncomfortable, you start opening up. You start. And so you typically have on your person, you have a skin layer, like a Under Armour type thing. And next to that skin layer is a light fleece, and then a heavy fleece, and then you typically have a wind barrier, like a nylon barrier, and then you have a light down, heavy down in your outer shell. And those things have zippers and stuff you can open up so that when you start to get warm, you start to remove clothing. When you start to get cold, you start to add clothing. So if you're doing
so moisture,
you got to monitor stuff. You have to have and your boots, for example, the boots we have.
This is something that I kind of deal with, because we deal with a lot of keeping people warm, but keeping people healthy is two different things. Because people think that I'm just going to insulate my house and I'm just going to carry on living my life. I'm going to keep producing moisture and then wonder why my house is getting moldy and why my kids are getting sick.
And then all the radon buildup and So yes, you have to. So you monitor your clothing, but the other thing you have to do is the way you stay warm is you eat.
Right.
Your body generates the fuel. So when I go to Antarctica, I'm on a calorie diet somewhere between 3,500 to 4,500 calories per day. At 3,500 calories a day, I'm losing weight. And the doctors their monitor, they're pushing you to say more calories, right? Because your body is going to burn those calories, and that's your heat source that your clothing minimizes the loss on. So you have to have food to keep your internal engines going, but not overheat, but not underheat. You have to avoid contact with obviously frostbite, but also the ultraviolet radiation. And then you also have you have the problem with high altitude. So you got altitude sickness, where in average you can come down the mountain. When you're in the middle of Antarctic Plateau, you're 2,000 kilometers away from the nearest low altitude. So you can't get into altitude sickness. You may be in a weather situation where you can't move for days. So you want to make sure your breathing system is never, you don't get behind in your breathing. You don't get behind in your cold, because moments like that can run out of control and you can be in really bad situation right fast. So you have to be working. So even like your boots, right? I have we have these boots that are good down to minus 70. And the boots have, there's an inner sock, outer sock, inner liner, outer liner, shell. So 5 layers on the boot. And it takes a while to get into them and so forth. But in the edge of the boot is little bristles, and you use your toes, you move them against the bristles to see, can I still feel my toes? Right? Because you don't get your toes starting to be norm. So you occasionally, and you're doing this stuff, and of course you're out with a buddy and you're checking to make sure, hey, I think you got your ear beginning to be exposed on there. And so you check the other to make sure they're not being exposed to light out there. But if you go with people who know what they're doing and they watch out, it's actually very nice, because one of the best things about Antarctica is the silence.
Oh, I have tinnitus. That would be awful.
There's no internet. There's no radio. There's no airplanes. There's no automobiles, right? When the wind isn't blowing, which is about half the time, nothing makes a sound. You can even hear your heartbeat.
Oh,
you could
that's
just
creepy.
sit down and just do nothing, right? It's one of the and it's just to be out there looking at this plateau, the mountains, so forth, and know that the rest of the world is out there. It's the only place, by the way, that's COVID-19 free. They went down in lockdown in February. Didn't allow people in there, and so they've remained free there. But it is it's beautiful. The people you meet there are extraordinary. They have all the various stories from. People are quite friendly.
You gotta be.
It's considered if you're like 100 kilometers from somebody, it's considered impolite if you don't go there and visit them for first off. That's
and
what
you have led us into an inadvertent segue talking about silence, because that's pretty much wrapped up the show. This has been, in all honesty, one of the most insightful, informative, and fascinating shows that we've done. I've really, really enjoyed. On my behalf, but I'm speaking for me.
Thank you.
I don't know how the other guys feel, but that was brilliant. Brilliant.
Thank you.
Yes.
No, cheers, mate.
And Landon, if I can get you to commit on air, we'd love to have you back, because I want to talk about eclipses, which is our favorite thing to talk about.
Absolutely. And I will point out to as a closing cap, December 4th, 2021, there's a total solar eclipse that goes through the Yin Glacier, but near the South Pole. There's an expedition put on by Travel Quest. You can sign up for. They have about 40 slots available. If you want to go on ice, it's probably one of the cheaper ways to get on ice, and you'll see a total solar eclipse in Antarctica, which is a rare thing. Ooh. And they have an optional trip. You can go to the South Pole, or you can go off to the Penguin Recreated Waddell Sea and other sorts of things there. So look up Travel Quest International, the 2021 solar eclipse. We'll talk about that next time we come back on eclipses.
For sure. So we're gonna send Brenna, because she's the most experienced with the cold weather living in SoCal. We're gonna send Brenna down there, but we need you guys to help us crowdfund that. Go to www.patreon.com/thebinpodcast for Mikey, Brenna, Wayne, Cortez, and of course our esteemed guest, Mr. Landon. Thanks for watching.
What's
up? Thank you.
Thanks so much.
Thank you.
Thank you.
And Ed.
Are we off the air?
2 seconds.
Yep.